Do you have any left?
I got a bunch left, so you come to the next meetup, I'll give one to you. Would you like a Hugging Face t-shirt? Okay. Cool. There's actually a lot of materials. So what I was thinking was you guys can code along, but then I have prepared a Colab notebook that I will just run through, and then you guys can see what happens on it. I'll explain what's happening, and then I'll send it to you so you can like go home and run every single line yourself, play around with it. Okay, grab a seat. I guess we can just get started. So you all came here today to hear me talk about long-term memory and personalization. Maybe what comes to your mind would be like RAG, context window, something like that. But why? Why are we talking about this today? Well, anybody here use ChatGPT? That's such a dumb question, but anybody here don't use ChatGPT today? Okay, cool. So they came out with this feature recently where they say that ChatGPT can now remember certain things about you as a user. So you don't have to repeat yourself over and over in each new message thread. And this is not anything new. Like what we know about OpenAI, like they came out with Assistants API fairly late in the game when everyone else is already familiar with the whole agentic and agents concept. So when they came out with this feature, I'm like, hey, I already built something kind of open source last year, like 8 months ago. And what I built was an AI girlfriend. So I built an open source AI girlfriend, very small Python code base. But essentially what she does is you go and talk to her like how you would talk to your chatbot. And then after a while, she starts to remember things about you. And she saves that as a key value data structure on your computer. So like with most large language models, the context window is limited, right? So you can't really remember everything all the time. I mean, hopefully one day you can do that. But as of today, what you can do is, if you're a software engineer, you can kind of like be smart about it, which is only putting in the information that is required for the LLM to do the task at hand. Nothing more than that. If you can do that very efficiently, you're going to get the best performance, best cost per generation, and so on and so on. So reason why we're talking about this today is because if you're building in production, you want to save money. If you're building like user-facing applications, maybe you want better personalization, better user interaction, user experience. That could definitely put your application, set it apart from your competition. Or if you want to learn the inner workings of an AI companion, then this is what this is going to be about. Okay, so are you guys familiar with this meme right here? Like the 5 different tiers of so-and-so. So we're going to break this down into 5 different tiers of personalization. So obviously start with the first one. No personalization. This is like ChatGPT 1.0, right? Like you talk to it, doesn't remember anything.
Zero shot, right?
Yeah, zero shot, no examples in context. So this means, let me take a step back. So large language models are, I think all of them right now are stateless, especially the ones behind API endpoints. Maybe not Assistants API, because that one is stateful. That one actually keeps an ongoing memory of like what you're working on and stuff like that. We don't talk about that. That's behind API. That's not considered LLM. LLM's mostly stateless, which means it doesn't know what happened before, what happened after. If you wanted to know who you are, what your request was, your personal preferences, then you got to keep that chunk of text in every single request that you send to an LLM provider, or in the LLMs that you're generating on your computer locally. So that's the F tier, no personalization. Got to repeat yourself over and over. Okay, a step above that would be you would bake something into the system prompt. System prompt is just a prompt for most large language models, fine-tuned in the chat kind of way to kind of understand that, okay, the conversation is grounded in this context. For example, I'm here talking to you guys. This is a workshop. That could be a system prompt. And now everything that comes out of my mouth is going to be grounded in that context. The problem with this is that it's just not very flexible. So whenever you want to change that, you have to change the system prompt. So how can you be smart about it? So many things you can do, why this is the D tier. And then after that, you got messages history. So this is very popular for chatbot interfaces. You talk to a chatbot for like quite some time. You generate like some rapport between you and the chatbot, and now it remembers a few things about you, only because you've mentioned it in the current conversation. What if you closed the chat window? What if you like close the chat thread? What if you close your computer? What if you clear your memory, your RAM? All of that is gone, right? So not very flexible, but it works, and it could make some really cool demos on Twitter and whatnot.
What is the difference between C and D? How C is different?
So C is different because in my head, you're appending more messages into the message queue for the messages history. And then you just put the whole message history queue into your large language model's context window. For this one, for like models that are fine-tuned for like chat instructions, you just decide the first message, which is the system prompt. This is what this conversation is about. That's it. I'm not looking at the messages after that. Yeah, so system prompt and then latest message. This one, hello, how are you? My name is so-and-so. And then I like ballroom dancing. Now all of that is in your LLM context. So better than that one, entity memory. So when I say entity memory, does anyone kind of have an idea of what that means? What comes to your mind when I say entity?
Personalization things.
All right, 1% at a time. Who said that over there?
I mean, when I think about it from NLP, it's just things, right? Objects. That could be anything from a sense.
Yeah, things, topics, tags, traits, right? Things. How about you?
Well, I said person, place, or things, right? The same, yeah.
Yeah, so entities, things.
Yeah. The relationships, the whole model of entities, relationships, right? Things versus how they're related to each other.
Yeah. So what I mean in this context is that now we're being very selective about what we want in the large language model's context window. So we get to pick and choose what's important for the next message response. We're not going to look at all the message histories. We're not going to look at just the system prompt. We're going to look at specific traits about the person that we're serving. For example, you are a startup advisor. I mean, in this case, that's like an entity trait about you.
Yeah.
You are an advisor.
Yeah.
So as long as I know that, I put that into the context window of like, hey, Brad is an advisor. He knows about startup. Then I don't have to like keep track of what our conversation has been about. And that little sentence is so much more efficient than like, here, look at this list of 20 messages from the last 2 hours. Remember all of this about Brad. Yeah.
How is this different from the D tier, like the system prompt?
Yeah, this is a little bit murky, so I guess I understand that now. System prompt, rigid, it's like a string, right? Yeah. It's just like, here's what's happening, so-and-so. But your question is really interesting because using the same concept, you can kind of inject these entities, whether that into like another message from the assistant or the system prompt. So, yeah.
So is it like a combination of the two, like C and D?
Sort of, yeah.
Okay.
What exactly are you passing for the entity? Like how are they represented? Is it the entity name, the entity and the span, or is it like a knowledge base?
Great question. Yeah, no spoilers yet. We're going to get to that part. But yeah, at this tier, you're just dealing with strings. You're like, this is what this person knows. This is what the chatbot knows about the person. Here's the string. And then you're going to keep that maybe key value pair or string in every single conversation. Not being...
Entity and entity type. Just
Yes. So like, I like...
Strings or tokens at this point?
Once it's in the LLM, I guess it's a token. But when you're like outside of it, you're trying to like extract it. Everything is, I guess, string until it has to deal with it.
Okay.
Yeah.
But at every prompt to the LLM, it is going in as a token, right? Like to each and every.
Yeah, when you talk about the LLM, yeah. So now it's tokenized. But I think what you're getting at is it being saved as string
Or
for
saved
our
as token,
purposes?
yeah.
Or is it being saved as like embeddings or tokens or whatnot?
Yeah, embeddings, right?
Yeah.
Exactly.
So that's the next part. Okay, so A tier. A tier is just like, at least in my head, I only know so much about this stuff, but this is the top tier. Being very selective about what you want the LM to know at any given point, because there are a million things about a person, right? Where they work, what they like to eat for dinner. For entity in memory, you kind of have to keep that at all times.
is there memory that you're storing at each time?
This part. Yeah. So here, if you're very smart about it, you can use something that has a vector database that has similarity scores, like using Cohere re-rank or Pinecone to kind of like get the score and be like, okay, above and below this threshold, I'm just gonna reject everything. And in this conversation, I only care about things that are above like 0.7 or 0.8.
Or ordered and only take the volume that you can handle.
Yeah.
Right, so you have a cutoff. Well, you do have a cutoff too, but often you might stop at 0.9 if you have a lot of stuff.
Yeah.
At the 0.9 and above, right?
Yeah, and you can do that like programmatically, just like comparison. Any question? Yeah.
Why is this different from a RAG? Like,
This is a RAG.
okay, yeah.
I'm talking about RAG right now. Okay.
Table augmented right there.
Yes, you're absolutely correct. You got me nervous there a little bit. But. All right, so.
Sorry about that.
Wait, there's no S tier?
Oh, well, we'll get back to S tier. As long as you stay for the entire thing, I'll talk about S tier. If you have an idea for an S tier, you gotta let me know too. Okay, so I prepared like this Google Colab notebook for today. Initially, I wanted to just kind of like code it out and then have everyone kind of follow along. That's why you guys brought laptops. But I ended up writing a lot, so it's a lot of like, materials. So I'm just gonna like explain what I'm doing on my computer, and then if you guys have questions, you can ask away. So what we're gonna do is just go through from F tier to A tier, and then just try to set up like a couple of like example use cases. So first thing we're gonna do is obviously get our Lord and Savior's SDK, OpenAI, installed on our environment.
All your examples OpenAI?
Say that one more time.
So that the engine you're using today will be
Yeah.
OpenAI's?
Yeah. So again, like this concept should be like model agnostic. You can use whatever model you want locally, whatever providers you want. Apparently Cohere is cool nowadays, so have some of that Canadian pride, I don't know. Okay, so OpenAI is installed. That's all I did. And now I'm gonna put in my API key. If you like look really quick, I'm gonna take a snapshot of this. Who said that? I'm just kidding. No, Parisa.
My Meta Ray-Bans just picked it up.
Explain to me what's on the screen right now. Extract the text. Okay, so I got my OpenAI API key in. If you were lucky enough to get a snapshot of that, Parisa is gonna delete the key tonight. So, nice try. All right, so got the key in, just set up an OpenAI like client from the SDK, and then this is the F tier, right? This is the shittiest version of the chatbot you can make. If this was 2022, you can probably like go viral on Twitter, but now you can't. Now people are gonna like, make fun of you. Okay, so system message. This is just the first message in any chat fine-tune instruct models. I'm just gonna say here, you are a helpful assistant. Your main goal is to blah, 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 and then speak in pirate speak. So that's the only thing that I did to like juice it up a little bit. Okay, so we got the message, system message in the message history queue. Now I'm just gonna create like a utility function just so that, it make my life easier. All this does is you pass it a string and a list of message history, and then it'll just stream tokens back to you. So that's just what it does. And now we'll just say, yeah, this is the streaming like display part. Okay, tell me a joke. Yeah, so it's not very like impressive, right? That was the F tier. What do you know about me? Okay, I don't know anything about you, but I can speak in pirate speak. Not very impressive. Move on to the D tier. Okay, so D tier. Here, what I say to it in the system prompt, this is the system prompt part, right? So all I say is, my name is Hai, and I'm currently an unemployed, washed-up full-stack developer, and I don't like chocolate. So there are 3 things about me. 3 things about me, 2 things are true. You can guess which one is true and which one's not.
I hope that is not.
Okay, so Now I'm going to ask it, what do you know about me? Of course, it knows that I'm a former developer who's currently not working, and I don't like chocolate. So D tier, not very impressive. Let me ask something that it doesn't know yet. Do I like baseball? No, it doesn't know. So, some gibberish answer right there. Okay, let's move on to something more interesting. So C tier, messages history. Now, let's say I want to give it, some more messages before the message that I sent it. I say, I like to boogie all night long. Save that to my message history queue. And then just want to double check and see if it's in the queue. Yes. In case you're not familiar with like how chat models work or like to see content, it likes to see user and assistant as the roles and the content as the text string. So I'm just going to append it here. Just a regular, object in a list, and then get my AI answer. What kind of dancing do I like? So now it looks into my message history and be like, okay, I'm gonna pull in like the dancing type that you like, so it knows. Now it gets more interesting. I feel like this is the part that you guys are gonna be in.
I understand there are 3 roles. There's like user, AI, and then system. How do they differ aside from just the way the text is dumped into the LLM?
That's a great question. I don't have an answer, but I do have a hypothesis.
Okay.
So recently, OpenAI came out with a bunch of recent articles about, hey, this is how we structure our training for our models, and I feel like that's the first step to open sourcing some of the stuff, maybe from the pressure from the community. So maybe from that, over time, we'll know how these models, especially GPTs, are, look at and pay attention to this different system or user or assistant type of messages. Apparently, from OpenAI's documentation, many months ago, it says that as long as you put something grounding in the system prompt, it's supposed to look at it with the most amount of emphasis. But we all know that they just freaking hallucinate all the time, right?
Right.
So, on paper, system prompt's supposed to ground the conversation. In practice, your mileage may vary. So yeah, I hope that.
Yeah, I mean,
answer
I've
it.
been injecting system prompts in the middle of conversation.
Oh, that's interesting.
And I've just been testing how does it differ from a user prompt, right?
So how has your experience been having user assistant and then system and then
I mean, in your case here, you spoke as the user, but you label it as system. So if you were to change system to user, would it provide the same output? I'm not sure. I put asterisks around all my system prompts.
yeah.
And that kind of just tells kind of a narrative about the story. Whether that has an effect or not, you could put asterisks in your user prompts too, and so I don't know. I don't have an answer.
Yeah, my simple understanding is the system one is meant to be hidden prompts.
Oh.
The user prompts tend to be, if you're in a chat, it's going to be stuff you see coming back and forth. So it's how you put in hidden content into the prompt window. That's my simple understanding, right? And it's how, and it's also how some people got it, or supposedly how some of the trouble happened with Gemini and their diversity stuff, right? Because they were inserting system prompts that says don't offend anybody, and all of a sudden it's turning into unexpected results, right?
Right.
And they're saying, well, how'd that happen? Well, it's because there's these hidden prompts, system prompts. So they call it something else on Google, but it's hidden versus explicit, right?
Yeah, I guess the concept is hidden from who, right? Because
From the user.
Yeah, exactly.
I think that's my take.
Yeah, just an aside, I had a chatbot where I wanted to have the AI just kind of continue the conversation if the user wasn't speaking. So I would inject fake messages hey, can you elaborate? But the user wouldn't see that in the chat window.
Yeah.
And it would just kind of continue the conversation. And then I switched those to system prompts, and it was pretty much the same result. So
Interesting.
yeah.
See, it almost doesn't matter.
Yeah, I don't think it does really.
Yeah, good idea. I can play with this as well and see what.
Yeah, you just on the back end, you just inject you have a timer. It's oh, the person hasn't spoken for 30 seconds. Can you elaborate?
Yeah, that's an interesting user experience for sure. Yeah, almost like a real person, right?
Yeah, I'm trying to make it more conversational, not so much type, wait for an answer.
I'm gonna steal that actually from my app.
The can you elaborate method.
Yeah.
It could be system or it could be user. I guess it doesn't
I think
matter.
I think it's treated the same. It's a good experiment, but I think the difference is if you're thinking about it from a UI standpoint, where you're
Totally.
Where you're using that, all of a sudden you can separate out what you show versus what you don't from a UI standpoint.
Right.
So I think it's more for that purpose.
Do the non-instruct models also have the user and assistant?
I don't think so. It's like a completely different,
Yeah,
like,
so
yeah.
I guess it's just like a training thing, right? Because the system kind of sets the context for the chat and then it trains with the user and the human, I mean, the assistant and the human.
Yeah, I
whatever
think of it like a narrator almost.
But I found the system messages helpful if you're using the LLMs for other tasks, like say classification or sentiment. or
Oh,
stuff like
yeah.
that. So you can kind of set up the context as, say you're trying to do zero-shot classification or something, and you know that the domain of the data set is something, so you can kind of set that up, and then you get like good results. So.
I think it makes more sense from like a production point of view where you want it to do like a specific
Yeah.
task, and it's like you said, like if
Yeah.
it's like a summarization task, or so if you have like a drop down, it will put that thing, and whatever you put in, you can just put it in like your text, and it will automatically ask the LLM based on your selection to do whatever task it wants.
That's
So it's more from like a back-end point of view.
Yeah, so it sounds like some people think that it's for like a kind of like GUI user experience perspective. And then it's also maybe because of like fine-tuning and training and how it's trained. I don't know.
Exactly, it's all about training data.
Yeah.
If it is like user, if it's structured like user assistant, it would go that way.
Yeah.
I tried like game player, or just remove it or something like that. So it makes sense.
Yeah,
Even different models on Hugging Face trained differently.
Yeah, exactly.
Sometimes it's Frankenstein, so they accept like every structure of prompts, like
Yeah.
every template, but they sometimes
Yeah.
you have to try differently.
Yeah, and going back to what you said, I actually have like an extraction LLM chain here, which uses the system prompt instead of like a message history like user and assistant, because I don't know, in my head it just makes more sense. Like system prompt extract these entity instead of like, oh, we talked about extracting entity in our last conversation. Like, but cool. All right.
Just the last point to add. Anthropic had released their system prompt per se, and they don't refer to the AI in like an entity itself. They don't use the term like you are a. They generalize it in like kind of like this hierarchical third perspective, and apparently that's been valuable for them in creating the assistant persona. And you could look them up online. Like all the system prompts that Anthropic has created for like Claude are all available. You can check them out and try them yourself or iterate them.
Would you be able to send me that after today so I can like email blast it to everybody?
It's there.
Sweet. All right. You guys ready for the next part?
Just one thing.
No. You keep that till the end.
Okay.
It's my time now. Just kidding. Yeah, we only have an hour and we get kicked out of the room. So that's why Parisa is here. She's here to. She's here so
Yeah,
that.
I was surprised it's only 1 hour. So let's.
If we got 2 hours, we
Let's
got
wrap up, yeah.
2 hours. I'll let you guys code with me, but like, you know, you get what you get. All right, so entity memory. All right, so this gets more interesting than messages history. So like you said, I have a entity extraction chain here, which is literally just an LLM call with the system prompt of like, looking at the user's message, you must extract the likes and dislikes as strings and then respond only in JSON in this format. And the cool thing about OpenAI is that their models, their API endpoints have this setting where you can say that I only want JSON output, which is super cool. This is literally what brought a lot of people back to doing like AI agent stuff, because before it was literally like, you can't even generate a proper JSON. Like it works like half the time. But yeah, I don't know about you guys, but I'm pretty excited about JSON mode. Anyways, so this whole function, all it does is you pass in a user's message and it spits out a JSON, I guess in Python, a dictionary. And then the keys would be likes and dislikes, so things that the person likes and the person dislikes based on the message. For example, I say, I don't like Red Lobster, or just too obvious. I went to Red Lobster and I had like a terrible time. Red Lobster would go on the dislikes array, which is up to the interpretation of the large language model. Okay, so we got that. I think I gotta run this cell real quick. Boom. All right, so now all I want to do is I want to just pass in a sentence and be like, sometimes I'm really sad. I go on long walks alone. Then I come home and eat a bowl of ramen. I usually don't watch TVs at night when I'm tired. Blah, 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 blah. These are all true statements, by the way. And then from this sentence, I ran my entity extraction function, and I got this nice JSON back. This is GPT-4, by the way. Like, this is like bulletproof. I made sure I used GPT-4 for this workshop, otherwise I'm gonna be messing with this like all day.
So you did specify 3.5 2 lines up.
Yeah, right above. Yeah.
Why did I take unnecessary risk? That's even more impressive, right? Like, things have gone a long way. Okay, so dislikes watching TV at night when tired, staying up late using the phone. That's actually not true. I like staying up late using the phone. Likes long walks alone, blah, blah, blah. So it works. Classification, NLP task, very, very straightforward. All right, so what I want to do now is just kind of rewrite our AI answer like getter. So what I want to do is I want to clear all the message history at this point, only keeping all the entities. So it doesn't know what we talked about before. It only knows the things that it knows about me from maybe a JSON.
Well, that's a system message, right?
Yes. Well, I don't remember, but I think so. Let's see. Message history that append role assistant. Actually, no, it's actually an assistant message. So yeah, in this case, it almost doesn't matter because like the example is so simple. So I'm just like, I don't want to inject strings into a system message. I just want to add another message into the message queue. But in a sense, the message queue is completely empty. It's just literally a line that says, the user's preferences are as follow. And again, this comes back to like using vibes to like deal with ChatML. I personally like to use these tags. I know some people like to use Markdown. I don't know which one works better. Does anybody have an opinion on this?
Depends on the model. Can't say for OpenAI.
Yeah, if it's smart enough, it knows. Some people use like XML tags. Yeah, but as long as you have these tags, at least from my experience building in production, the attention is paid to the right places, which is really nice. Okay, so pretty straightforward. All I did here was, before the AI generate a new message, just insert into its own context window that here are the things the person likes and dislikes based on whatever. Okay, so let's run this function, this example right here. So literally just says, I've been craving to eat avocado toast like a true millennial. And then I asked for some recommendations for like, give me like something bougie for a millennial like me to have for breakfast. So it was able to extract some of the entities out of that. And then it'll just give me some silly recommendations. But this is the fun part. This is the fun part. This is when it knows a little bit about me. And then I say, when I'm sad, actually, did I just repeat this? Never mind. That's what happens when you code at like 5 a.m. in the morning. Okay, we'll just skip this part. But you get what I'm saying, right? So you extract all the dislikes and likes from the person's message. You kind of keep it to the side. Maybe you have like a Redis database, some key value, like lightweight database, maybe even SQL, Postgres. And then you just kind of pull those things back in for every single message so that you don't have to keep a long running conversation about the person just in order to know who they are. Because we can kind of pick and choose what we know about people, right? Okay, so now I can ask for a recommendation. Like, I'm bored. What do you think I should do? The reason why these two arrays are empty is just because this sentence doesn't have any likes and dislikes in it. But it knows that I like to relax and go on long walks. It'll just tell me to do something that's along those lines. So if you're thinking about personalization for your own application, this is a very lightweight, again, like a lightweight and efficient way to make sure that the LLM knows who the user is, as opposed to like, here, let's bring back all the conversations from the past and then try to make it know who they are.
Pretty cool.
Yeah, you think it's cool? Oh, thank you. Any questions about anything? Thought I heard somebody. Yeah.
I guess you could just do like summarization as well. So instead of like likes and dislikes, you just say like summarize the last little bit of conversation and just kind of compile that.
Yeah.
In a sense.
So I know you, we were talking outside, you said that you do summarizations of past message threads and then you bring that to the next one, right? How has your experience been with that?
Well, it works well because, like we were saying, at some point, there's just too many messages, and the language model can forget what you said some time ago. And the other thing is, in our case, we want to display in the mobile app a summary, like a list, and you can review your answer. You can even change them by the mobile app. And when you ask a question again, we will send that summary back.
Yeah.
I have also similar experience. So after my chatbot has, so when I got like answer from the LLM, I save it to database the full answer, and then I summarize with a quick model and this save at the same row summarized, and then when my context window is too long, I start using like summarization.
Yeah.
To fit. I start replacing like old ones until I fit. But this one is much better because you can you can lose data when summarizing, and you don't know what actually it returns to you. But this one is very good.
Yeah, so for summarization, it's almost like a lossy way to compress things, right?
Yeah.
So as you compress your conversations over and over, you kind of lose things, and over time, it kind of like, unless you specify what important details you want it to remember, the summarization will probably like maybe lose that detail over time.
Yeah, that's what I was thinking, because in my experience, like I've tried summarizing things, and sometimes until it has like a good amount of context for what it is going to be used for, it does lose information from time to time.
Yeah.
Whereas your model, I feel, so for a general model, like a summarization feels like a better option. But like if you have like a specific use case, then because like likes and dislikes are specific things that you want your model to sort of remember.
Yeah. So summarization is still a great technique though. Like as long as you're still in the same conversation thread and your conversation is going for a long time, then yeah, summarize it. That way you don't lose a lot of like details, important details. But if you have a conversation, we have multiple conversations over time, and then you keep summarizing over like on top of other summarizations, then probably you'll lose some resolution there. And this.
It would be cool too. So if you just give me a summary, but paying attention specifically to likes and dislikes.
Yeah.
What's the best word for that?
Exactly. However, the stuff that I just showed you, or even summarization, some of that is done on like a separate database or data structure, but some of that is probably done in memory. Even if it's done in like a separate data structure, like, it's still not really scalable, right? What if like you have like a million things you want to remember about the user? You probably know the answer by now, right? Like, what is the answer when you want to just be very selective about?
Rags.
Vector database.
I was waiting for you to say it. Would you like to say it?
Like just put database.
Avocado toast.
Exactly. Just insert like user likes avocado toast in every single message. And then the millennials are like, how does it know? Like it just knows me. This is the best thing ever. This chatbot is so much better than the other ones. Oh my God. It really speaks to my generation. Okay, so A tier. All right. This is where I'm actually gonna get like Pinecone set up. And yeah, we'll see. So Pinecone, in case you don't know, is just a very popular way to do to save embeddings and do, it's a data structure that you can use to do like similarity search, cosine similarity, a bunch of other things. That's the only things that come to my mind right now. But it's very powerful. Recently, they came out with this tier that is completely free. I don't work for Pinecone. I sound like I'm shilling them, but essentially, it's now serverless. You can choose the serverless instead of like an actual pod. So it used to be very expensive if you like choose to go with their pods, which is basically like an EC2 running like 24/7. But now you can do serverless. So very cost effective, low latency, and it has a free tier as well. So definitely like check it out.
Do you use PG Vector on Postgres at all?
I personally use PG Vector. I'm a huge Postgres fan. I paid nothing for my data structure, which is amazing. And it's all from like the reports I've seen. PG Vector. If you guys are into like SQL databases, there's an extension called PG Vector. You use it. You pay nothing for like these like hyped up AI companies, but just trying to make this low risk. I'm just going to use Pinecone because it's production ready.
I mean, you're in a collab, so yeah.
Yeah. Otherwise, I have to set up like a whole like shebang.
That's a lot of work.
But if you start thinking of production application, I definitely lean towards something like PG Vector. Right?
I am using PG Vector,
for
so
production
we gotta chat afterwards. I can talk all about it. That's all I think about every day. Okay, so again, gotta get my Pinecone API key. Nothing is free nowadays, unless you're on PG Vector, man. Okay, so I got my Pinecone API key in. It's completely free. You can go and sign up for one. Let's just set up.
What does it do?
Oh, Pinecone. Okay. Pinecone is basically a vector database. So if you ever heard of like FAISS, which is an open source project from Meta, or Chroma.
Why do you pay for that? Do you mean that they host your database?
Yeah, they host your database, your embeddings.
Can't you just spin up a container locally?
You can.
Yeah.
You can.
Okay, I see. Yeah, I see.
I'm just scared of looking stupid today, so. But you definitely do that. If you use like Chroma DB or something like that.
Postgres I use.
Or yeah, Postgres again, PG Vector.
Yeah.
But today we're using Pinecone because it's just look at this.
For demonstration, it's good. Really good.
One-liner. You get a vector database. And here's the fun part. I've been diving into like embeddings recently. But essentially, OpenAI came out with their new set of embedding models, which is OpenAI Embeddings V3, I think. And essentially, based on the leaderboard on Hugging Face, you can get almost the same type of tier of performance compared to the last generation, even when you have like half of the embeddings. So the default is like almost like 1,500 vectors, dimensions that you have to save for each embedding. But you can reduce that to like almost 512 and have almost the same performance as before. The reason why I say this is because I like cheap stuff. I don't like to pay for I don't like to go over the free tier on my Superbase. That's why when I heard that you can get the same performance, man, I'm like, yeah, I'm gonna just delete all my old embeddings and then just re-embed, and now everything is smaller. The reason why you want it to be small is because you save money on your database, because embeddings are huge. It'll take up a lot of storage on your database. And performance and lookup. So if you're paying for Pinecone and you're like, I'm gonna go for the best embedding model, I'm gonna just get all the dimensions in there, your search performance might be great. You might have 10% more than what I have, but you're probably paying a lot more. So in most use cases, just go for like the bare minimum. It's probably gonna be fine. Okay, so real quick here, just setting up my index in Pinecone. So yeah, setting up my index, and then that's just a place for me to save my embeddings. And then, yeah, that's pretty much it. Save my, create my index. It's gonna take a little bit of time because we're sending like a request to their server. This is the.
Does this use document DB under the hood now, or what?
Say that one more time.
Does this use document DB under the hood now? Because I see you got AWS USD still in there.
For Pinecone?
Yeah, I'm wondering what they're using on AWS for the backend.
I actually have no idea.
Probably document DB. Gotta be.
Would you like to tell us more about document DB?
What is document DB?
Yeah.
Just
MongoDB.
like
It's their MongoDB.
It's their MongoDB version, yeah.
Yeah. It's like their
Key value store. Yeah.
their open search is really Elasticsearch. The document DB is really, and they have a equivalent to Postgres, what they call something else too.
Interesting.
They have a name that's really Postgres, right?
Document DB is Postgres under the hood, but you can
Ah.
Is it Postgres under the hood?
yeah, and you can
But it's
But it's
now
a
with MongoDB
it's
in
a
terms of its.
NoSQL, yeah. So
yeah.
you could connect like mongoose to it,
Yeah.
and it like acts like MongoDB, but under the hood it's Postgres. It's
Oh.
super weird.
Everything
so
should be
funny.
Postgres anyway.
That's so
I'm glad to
funny.
I
hear
mean,
that.
Postgres is so good, right?
Exactly.
So,
I was
It should all
gonna-
be Postgres.
I was gonna say two types of people: SQL, NoSQL. Boom, one type of people.
yeah, there you go.
It's just the API layer on top of it.
Yeah, yeah.
Yeah, when
Wrappers
Postgres
on
added
wrappers on
Yeah.
wrappers.
binary
That's all
JSON,
Yeah.
I use
game
that.
was over.
Yeah. You got structured data and unstructured data in the same place.
Yeah.
All right.
The wrapper over zeros and ones.
All right. So here's where I'm going to use LangChain, because when you cut your embeddings in half when you're using like OpenAI's like embedding v3, there's some math you got to do to figure that out. I'm like not that great at math, so I'm like, let me just use the wrapper library that everybody hates, which is LangChain. Probably shouldn't say that on camera because they're a sponsor.
Everyone loves that, right?
Say that one more time. Everybody loves LangChain.
Everyone loves
Okay, so LangChain is installed. Just gonna set up my embedding client here. I'm using the latest and greatest text embedding v3, small. There's a large one, and there's a small one. The large one is about 10 times more expensive, but they're both very capable. Like,
What tokenization does it use to
I actually don't know. But if you send me an email, I will find out, and I will send it to you. Because now I'm thinking about it, and like, I actually don't know.
Just
I guess it's-
ask Perplexity.
The high model wasn't trained on that information, sorry.
Yeah, my training cutoff is 2016. That was the best year of my life. Okay, so we got that. But if you send me an email, I will find out enough.
Hey, I'm looking for it.
Yeah, if you find out what the answer is, you gotta let everybody know. Okay, so basically what I'm trying to do here is same thing. So run the extraction pipeline chain so that I get all the likes and dislikes out. And then I'm going to save and embed all of that and then save it to my vector database. The reason why I'm doing that is because eventually I only want the ones that are relevant to like, my conversation. You know, I talked about like taking long walks on the beach, like eating avocado toast, unemployed. I don't know, is that included or? Probably not, but a bunch of stuff, right? But if I want to ask for recommendations about like, what should I cook tonight? It doesn't need to know that I like to take long walks on the beach. Probably what it wants to know is what I've eaten in the past and liked to eat in the past. So that's all this does. It's a bunch of utility functions to basically be like, okay, so, and here's another trick. Anybody here deals with embeddings a lot? You sound like you do.
Not much. We don't really do much, right?
Okay.
We had to embed the whole Canada.ca website data, all the summarizations.
Oh, wow.
So that was a pain and very expensive. But thankfully the clients gave it.
Okay. And you're saying something?
Yeah, I was using them for within Stable Diffusion,
Mm-hmm.
but they kind of that scene kind of moved on to LoRa's a little more. But I'm not sure where the LoRa state is with LLMs. I think that's perhaps a pipe dream, the Q LoRa and all that jazz. But yeah,
Yeah, I looked into that. It's pretty interesting, like in terms of
but embeddings are very small compared to like a LoRa or like a full fine tune. Embeddings are like the smallest.
Right.
And yeah, I guess they basically excite a certain part of the LLM.
Yeah.
From what I understand.
Is it really more from like the architecture point of view?
Yeah, I think he's talking about like embeddings in terms of like large language models. I think what we're talking about is more so like embeddings in like the RAG context. But in the RAG context, what I was gonna say is when you're embedding any chunks of text, you don't have to so what you can do is you can take you can enrich it basically. So this is your chunk of text. You can like embed also like a pre-context and like post-context of it. So if your document has a name and a summarization, throw it all into the same embedding. You don't have to save the content into the same place, but you can embed them together so that when you like do cosine similarity like search, those things get hit more frequently because then the chunk of text is now in the context of like this document with the summarization as opposed to like by itself. Is that one more time?
Like a metadata?
So metadata is more for filtering. So if you do hybrid search, you can filter like with structured data and be like, okay, I want this document, I want that document. But you want to hit the embedding in the meanings of the document. That's what I mean. So like just insert the document's lesson, the document's name and the summarization into each chunk when you embed. Don't save it as an original source, just when you embed. And now when you search with those things, those meanings in there as well. So that's just something that I started doing recently with great results. I just wanted to share with you guys. So vectorizing. So let's say you have a chunk of text. You vectorize it, you get some like floats. If you vectorize that plus more text, now the meanings is a little bit different.
Oh, so you're saying you vectorize the embedding in text?
So you know, like every document you embed every chunks of it, right? Because like the documents are long, right? So when you embed the chunk, normally people would embed just the chunk on its own. Maybe save some metadata on the side to query it later.
Okay. Oh, so you're saying just combine everything and just...
Yeah, combine everything. So like every single chunk, just summarize content. And then once you search for it, then the meaning is more complete. You get like, anecdotally, like 20% more performance. At least from my experience. I love it. So, recommend it. Okay.
Now, are you saying, just to be clear, so I have a big document.
Yeah.
And I basically take a summary of the document
Mm-hmm.
and take an embedding for that.
Yeah.
I take that and add it to each
Well, no,
chunk.
you take the text of the summarization. You just like
Yeah, okay.
naively like insert it with the chunk that you're trying to embed.
Right.
When you're trying to embed that chunk,
Right. So the chunk has the
the meaning of the summarization in it.
summarization
Yeah.
with it.
Yeah.
The summarization of the entire document or just the content of that?
The whole document.
Chunk.
Entire document. Especially when you have multiple documents in the same knowledge base that you're trying to like hit. So now you know that, oh, you're getting this chunk, but in this context. You're getting this chunk from this context. Not like chunk, because chunks can be small or large, right? Chunk might not have enough meaning in it. So chunk in the meaning of this document with the summarization. Anyways.
You could also do something more interesting is like have like a weighted of the previous context and the like.
Yes.
Have like a weighted summary
Yes.
and then,
Yeah.
add that. So it knows exactly where it is in the document. So you could also maybe add localization.
Yeah.
Like where it
I
is.
want to get as much enrichment in the embedding as possible. Yeah.
No, but wouldn't that make it more difficult to find? Because let's say you have like a document for like a tutorial of let's say Azure, and you have like a summary of the entire thing.
Mhm.
If that is there in each and every chunk that you have put in, so wouldn't it sort of ping for all the chunks?
It's summarization and the real content.
Yeah.
Yeah.
But the one that's more relevant will still score higher. That's why
Yeah.
the scoring, the coastline match you pick the highest matches first. So it's
No, but if there's not a lot of information, let's say about one particular command, which comes in, let's say once in the entire document,
Mm-hmm.
it is there in the what do you call it, in that particular content, in that particular chunk, and it's also there in the summary. Then like the difference is not a lot. Like each and every chunk will have that one particular, let's say, command. Are you getting what I'm-
Are you saying that if you look for something that's actually inside a summarization?
Yeah.
Okay, yeah.
You're talking about very short
Like
message,
there's like a
right?
particular piece of information which
Mhm.
is there in the summary, but it is also there in just one chunk. Then like the difference.
Here, I got a remedy for you. What you want to do is just top K 10, 20 documents, stuff into your GPT-4, and let it figure it out. Yeah, and burn the tokens. So edge cases, right? Like
Yeah. I was thinking.
that's a good question though. Okay, so
Don't summarize if you have like only like
Yeah,
250.
that's what I-
yeah.
Yeah.
Okay, so this is my last magic trick. I'm gonna sort of run this and say, I like running, and I like donuts, especially donuts. Everybody here tried Cops donuts?
Oh, Cops Toronto, right?
Yeah,
Yeah.
the best donuts. They're very small. I don't know why I'm talking about donuts. We're gonna wrap this up. We're already 2 minutes over time. Okay, so got a bunch of stuff. I'm gonna run another one just to give it more information about like who I am and stuff like that. I like to travel. New York City is beautiful, stuff like that, blah, blah, blah. And if we go here, we can already see like our embeddings start to get saved here. Running, likes. These are just my metadata. Shoes falling off. Did I say that?
When did you add that? Yeah, it's just,
I'm just running a bunch of sentences here, so
Too much cheese.
yeah,
I think it's adding from like your previous runs on the same thing.
probably. Okay, so final magic trick of the day. Okay, so I need to eat something. This is the ultimate recommendation task, right, for AI systems. This is what Silicon Valley money has been poured into. This is the ultimate first world problem that we have to push our boundaries to solve. What do I want to eat right now? So based on that, this is the fun part. I'm going to run cosine similarity and just get the thing that I need. It doesn't need to know that I like to run or don't like cheese. I actually should know that I don't like cheese. But my top K is 1 right now, just to prove a point. So it's got the best result, which is I like donuts. And then it gave me a good recommendation, which is more donuts. So
All right, be back in 4 hours while we drive down to Great Cobs.
exactly. But that's it, everybody. That's the webinar. So awesome. All right, I think we're gonna get kicked out, right?